All right, so lesson 6.4 is homework. Fill in the blanks. The set of order pairs x, y that satisfy y equals mx plus b, and this is our slope-intercept form, is a line where slope is represented by something and y-intercept is represented by something. Okay, so this is our standard slope and intercept form. So m is our slope, so slope, the blank next to that would be m, and the y-intercept is represented by the b. Okay, number 2. So number 2, family's taking a car trip. They expect to pay $150 for someone to look after their dog, and they think it's going to cost $200 per day for a room and meals, and $80 per day for other expenses. So if you notice, the 200 and the 80 are both changing per day, so they don't need to be represented separately. You're going to be going for a certain number of days. The 80 is going to vary by that number of days. So is the 200. So really, you can just put those together. You're spending $280 per day. So when you ever have that per day, that's what's being multiplied. So as we think back to this formula, the slope right there that's being multiplied times x, okay, that's going to be this number that varies based on something else. The 150 is constant. They're paying somebody $150 to watch their dog. That's not based on how many days or anything like that. That's a flat rate. So when we go ahead and write this, it's y equals 280x. So it's $280 per day plus $150 for someone to watch the dog. Now, that's letter A. Letter B, we're now making the connection between this type of equation and slope and intercept. If I was going to put this on a graph, I would start at 150 on the y-axis because that's the y-intercept, and I would go by this slope, up 280 over 1, because every day, every 1 day, that's my over, it's going up 280, so that's my slope. So for part B, what are the slope and y-intercept? So slope is 280, and y-intercept is 150. And number 3, determine the slope for letter A. So this is already in nice form. Y equals mx plus b. M is my slope. So m equals 2. Part B, determine the y-intercept. Always this plus or minus right here. So that's 3. And letter C, we're going to go ahead and graph the line. So just real fast here, we're going to be starting at 3 and then using our slope of 2 over 1. So you always just start on your y-axis. And I'm going to be starting at my y-intercept. So I know that this line hits the y-axis, so my y-intercept is 3. And then my slope says rise over run up 2 over 1. So from this point, I'm going up 2 over 1, up 2 over 1, up 2 over 1. If I was going to work backwards and stay on this line, I'd go down 2 and then to the left 1, down 2, left 1. Okay, so for any of these, the starting point is going to be your intercept, and then the slope is the directions on where you're going from there. So number 4, same idea. Letter A, the slope is always whatever's attached to x, so that's 1/4. And my intercept, now that's -2. When you see a -2, that's a -2. So now when I go to graph this one, I'm starting at my y-intercept, so it's going to hit the y-axis at -2. And then this is my slope, rise and run, up 1 over 4. So up 1 over 4, up 1 over 4, up 1 over 4. Going the opposite way, down 1, left 4, down 1, left 4. So it's going to look like this. So again, the key is you're starting at the intercept and then using the slope to go the rest of the way. Okay, number 5. Part A, rewrite it in slope-intercept form. Now this is already in good y equals form. Technically, if you want it in slope-intercept form, you're going to put it where the mx is first. So we're going to go ahead and just move that. Now since we're not moving it to the other side of the equal sign, we're just shifting it here. it has to maintain its positive or negative. So this is a negative 1.3x when I move it. And this 5.6 is going to move and it's positive, so I'm going to write plus 5.6. So I haven't really changed the equation. I've just kind of changed the order of this. This is still fine. You can still recognize the slope and the intercept, but if we want to put it in perfect form, then we do need to move it. So now from that, recognize your slope is negative 1.3. And part C, your intercept is the positive 5.6. Okay, right next to it, I'm going to do number 6. Now this one, you can see it needs some rearranging. It's not in y equals form. It's not in y equals mx plus b form. So we got to get y by itself. I'm going to minus x on both sides, trying to isolate this y. So now I have 5y still. On this side, I'm going to go ahead and put it in this order where the x comes first. So negative x, positive 7. I got to get rid of this 5, so I'm going to divide by 5. Everything gets divided by 5. So this goes away. Now I'm in good form because it's y equals. You can leave the x in the fraction, but if you think back to this question over here, you see how we've got the fraction in front of the x. It just more easily shows the slope. So I'm going to rewrite this. If the x is up there by itself and you don't see a number, that means it's really a 1. So negative 1/5 x plus, and I'm just going to leave it as 7/5. And now I can answer my question. My slope, so this is part A, this is part B. My slope is negative 1/5. And then part C, my y-intercept is 7/5. And of course, if you turn that to a decimal, that is a nice decimal, so that's perfectly fine. Okay, number 7. Your hot air balloon begins 3 feet off the ground, and then it climbs at a constant rate of 2 feet per second. So 2 feet for every second. So that's what's changing. That's what's varying based on the number of seconds. So that's my slope. That's what's going to be multiplied times x, which represents seconds. And my starting point is 3. So if I was just starting this out, I would say y equals, I'm starting at 3 and I'm adding 2 for every second. Now part A, they want me to write an equation in terms of h and t. So remember, this is 2 for every second. This is my t, and that makes this my h. So the height is equal to 3 feet where I started plus 2 every second, which is time. So I'm just rewriting this. Height equals 3 plus 2 for every second. Part B, draw a graph. Now I'm just going to draw a graph like this, one quadrant, because this is a specific situation where I'm not going to have negative numbers. My height's not going to be negative. It's not going underground. My time is not going to be negative. That's not possible. Okay, so when I go ahead and graph this, all I need is quadrant 1 with my positive numbers. And so this is my intercept. That's B. So that's where I'm starting. So at time 0, if you would plug it in, this would eliminate. And you're at 3, so the height is 3 at time 0. At time 1, we've gone up 2, so 2 times 1 is 2, plus 3 is 5. So at 1, it's up at 5, and that should make sense. I started at 3, and then I used my slope. This is my slope, up 2 over 1. So it's going to continue to go up 2 over 1, up 2 over 1. So my graph looks like this. My hot air balloon is rising. So part C, what are the slope and y-intercept? Slope is 2. That's what it's going up by. In y-intercept is 3. Now, how high is the balloon after 60 seconds? For this one, I would just go ahead and plug in. So since t represents seconds, I'm going to put 60 in there. So 2 times that is 120. So my final answer here is 123. Okay, number 9. We're going to write an equation of a line that's in slope-intercept form, y equals mx plus b, with the following characteristics. So it's going to be y equals, you're going to plug in your slope with x. So if my slope is 4, it's 4x. Intercept is positive 3, so plus 3. Number 10, the slope of 0, so that'd be 0x. Intercept minus 2. And this is good slope-intercept form. Now, of course, that would simplify out, and the x would just go away, and so you'd have negative 2. And we know what this looks like on a graph. Y equals negative 2. It's going to hit the y-axis at negative 2. And if you think about that, that's why the slope is 0, because it's going straight side to side. It's not going up. It's not going down. That's what these lines in y equals form do. Okay, number 11. Write the equation of the line graphed at the right in slope-intercept form. So first thing I do when I look at these is I actually look for my intercept. I don't worry about slope yet. So here's my intercept, negative 5. So it's going to be something x minus 5 because it's hitting at negative 5. And it looks like it's going up 2 over 1, up 2 over 1, up 2 over 1. So that means my slope is 2. Okay, number 12. They use this equation to make the following table and graph. We want to find the slope and the intercept and explain how you can find them in the table and the graph. So first of all, they've given you the equation. So my slope is 1/2 and my intercept is 2. And we want to talk about how we can find them. So you would say the intercept can be seen in the graph. You can also see it in the table. An intercept on the y-axis is when x is 0. So x is 0, y is 2. So I'm going to say you can also see the intercept on the table. At 0, 2. And then I'm going to talk about the slope. Slope can be seen on the table. Because every time I increase my x by 1, my y value goes up by 1/2. So it is increasing by 1/2 every time x increases by 1. So that's my slope. So you can see it's going up 0.5, 0.5, 0.5, 0.5 for every time x goes up 1. That's your slope of 1/2. And you can see at 0, 2, that's my intercept, and you can see that on the graph as well. Okay, 13, we're going to match the equation on the graph to the situation. So he's got $80 in the bank, and he's spending $6 a week. So I'm starting at 80 and I'm going down 60. So you can see I need a positive 80, not a negative. Positive 80 and going down 6. So for 13, the equation is letter C. And if I was going to find this on a graph, my intercept would be at 80 and I'm going down 6. So you can see I'm at 80 and these other two graphs are going up. So this one you can see is going down. So letter I would be the correct graph. For 14, he borrowed 80, so he's in debt 80, so he's in the negative, and he's going to pay him back $6 a week. So you can see the only one with the negative is right here, starting with negative 80 basically, but then you're going to add 6 every week, so eventually you'll get back to even ground. And so that's letter A. And the graph, you can see I'm starting at negative 80, and I'm going to increase by 6, and so I could calculate after how many, what are we talking about, days or weeks? After how many weeks am I going to be back in the positive, or at least pay my debt off? And so that would be graph triple I. And 15 now. Obviously, it's going to be the ones that we haven't used yet, but she's got $80 in the bank and is adding $6 a week. So starting with positive 80 and adding a positive 6, so increasing the amount in there, that's letter B. And we find that on the graph right here, starting at 80 and then increasing from there, so double I on 15. Okay, 16. Consider the line that goes through these 2 points. You notice the x value has not changed. Why does this line not have an equation in y equals mx plus b form? So let's think about that line for a second. If we're at 3, 4, and then 3, 7, we're still at 3 and 7. So the line that goes through that looks like this. It's a vertical line. So to answer letter A, why does this line not have an equation in y equals mx plus b form? Because the slope, it's not even 0. The slope is undefined. We cannot define that slope, so we can't write an equation in slope-intercept form. If there is no slope, it's undefined. And then letter B, what is the equation of this line? We've talked about these. The x value is not changing. It hits the x-axis. It's x equals 3. So not in y equals mx plus b form because the slope is undefined. We skipped number 17. So we are going to number 18. So a line has this equation. For what value of b does the line pass through exactly 2 quadrants? So let's go back to talking about quadrants here. This is a 4-quadrant graph. Quadrant 1, 2, 3, and 4. Forgetting what we're starting with here in general, if we're only going to go through 2 quadrants, it really doesn't matter what kind of tilt we put on this line because these go on forever. So if this is tilted up just a little bit and hits here, it's going to be up here in quadrant 1. Eventually it'll be in quadrant 2. And even if it's somewhere off our graph, eventually it's going to end up down here in quadrant 3. So it may never hit quadrant 4, but a line like this or a line going down is always going to be in 1, 2, 3, or 1, 2, and 3 eventually here. Going up, it's 1, 2, and 3, or it's 1, 2, and 3. But the only way it's going to ever only hit 2 is if it goes perfectly through the origin, either this direction or this direction. Now, it can go through the origin with all different slopes. It could be extreme increasing, but still only go through 2 quadrants, or it could be extreme decreasing and go through 2 quadrants, or it could be really flat through the origin and only go through 2 quadrants, really flat going down. So the key is that it goes through the origin. Now that's our y-intercept because it's hitting the y-axis. And so what's the value at the origin of y is 0, same as x. It's 0. So that's going to be our y-intercept. So b needs to equal 0. So I've got my equation, y equals negative 3x plus b. What does the value of b have to be? Has to be 0. Because if b was 1, it's going to hit up here. And when you draw a line that goes through that and it has a slope of negative 3, it's going down. At some point, it's going to be up here in quadrant 2. And if it hits up here, it's going to end up in quadrant 1. And then eventually it's going to end up here. So the only way it goes through only 2 quadrants is if it hits perfectly at 0, which means b, or the y-intercept, is 0. All right, we skipped number 19. We are going on to 20 to 22. So number 20, determine if the following statement is always, sometimes, or never true, and explain. It says vertical lines have a slope of 0. So remember, vertical is straight up and down. And so your answer here should be never. A vertical line can never have a slope of 0. A slope of 0 is going to go straight side to side. Okay, the slope is always undefined if it's a vertical line. Remember what a slope is actually measuring. It's measuring the increase, measuring the decrease. If it's going straight up and down, we cannot measure how fast it's increasing or how fast it's decreasing. Okay, if it is going side to side, we can measure that. How much is it going up or down? 0. How much is this going up or down? Can't measure it. So that is undefined. Okay, 21, we're going to solve this equation. So So this is a proportion. We have a ratio or a fraction equal to another ratio or fraction. So to solve this, we are cross multiplying. So going this direction, and remember, it doesn't matter which one you do first. I'm multiplying the 6 times this. I'm going to have to distribute. And if these are truly equal, then that means these cross products are going to be equal to each other. So 5 times 3 plus 2x is going to have to equal the same thing as 6 times 6x minus 4. We're going to go ahead and distribute now. So we're going to get 36x minus 24. And we're going to get 15 plus 10x. X on both sides. Get rid of the smaller of the two. So I'm left with 15 on the right, 26x minus 24. So I'm going to add 24. So this goes away. So I'm going to bring my work over here. So 26x equals 39. I'm going to divide by 26. And does not give me a nice decimal. It is a repeated decimal. But I can simplify this. 13 goes into both of these. 13 goes into 26. 13 goes into 39. 3 times and 2 times. So my final answer is 3 over 2. (22). Same idea. Now you'll notice the 3w minus 1 kind of sitting there by itself. So what do? Make it a fraction, put it over 1, and cross multiply. So it's going to be 3 times this, and 1 times that. So obviously 1 times that is not going to change anything. 3 times this, distribute, 9w minus 3. W on both sides. There'll be a teacher in there. I'm not sure who's on there on Mondays. They might not be in there right away, but they'll be in there.
All right.
You just hand it in to them when you're done.
All right. Thank you.
Okay, so this eliminates. We're going to have 8w minus 3 on this side. We're going to add 3 on both sides. So 8w equals 6. Divide by 8. So w equals 6/8, which you could write as 0.75, but it simplifies to 3/4.